All right, so this is day 5 notes, and we're talking about word problems with inequalities. So this box right here is very important. So maybe I would put a box around it so that you can find it very quickly in your notes. But this kind of changes the words and tells you what the mathematical symbol would be. So if the word problem says at least, then you're going to use greater than or equal to. If it says no more than, you're going to use less than or equal to. If it says more than, you're going to use greater, or if it says less than, you're going to use the less than symbol. So let's take a look at a word problem. Patty has $500 in a savings account at the beginning of the summer. She wants to still have at least $200 in the account at the end of the summer. She spends $25 each week for food and expenses. How many weeks can Patty spend money? So the first thing you want to do is identify your variable. What are you going to set your x equal to, or whatever variable you want to use? So in this case, the question, or actually in all the cases, the question they ask will tell you what you need to set your variable equal to. So it says, how many weeks can Patty spend money? So the number of weeks is the things I don't know anything about. So I'm going to set my variable equal to the number of weeks. So x equals the number of weeks. All right, well, let's go back and read our problem. Patty has $500 in a savings account. So that's what she's starting with. So I'm going to put $500 down here. She wants to still have at least $200 in the account at the end of the summer. So this is the beginning of the summer. At the end of the summer, she wants to have $200 left. She spends $25 each week. All right, well, if she spends it, then that's going to reduce her $500. So that would be minus $25. But we don't know how many weeks she's going to be spending at the summer spending money. So we have to put our variable in, x. And it says she wants to have at least. So if we look up here, at least means greater than or equal to. So I'm going to put my greater than or equal to symbol right in there. So now I have an equation that I could now solve in order to figure out this word problem. So let's go ahead and do that. Well, this is the term I want to get alone. So I have to move the 500 over to this side. Well, my 500 is positive, so I'm going to subtract 500. And just as an aside, the work that I show you on these videos is the work that I'd like to see done out. You need to actually show that how you're moving things. So this 500 will cancel on this side. I'll have a negative 25x here. I'm adding or subtracting, so I don't have to worry about flipping my inequality. 200 minus 500 will give me a minus 300. Well, now I'm multiplying between the negative 25 and the x, so I'm going to have to undo multiplication by dividing. I'm dividing by a negative, so I have to remember I'm going to have to flip my inequality sign. So if I'm going to divide by a negative, I'm going to have here, these will cancel out, and I'll have x. I have to flip my inequality, less than or equal to, well, negative 300 divided by 25, I'm going to have a negative divided by a negative, that'll be a positive. I know 100 divided by 25 is 4, but I've got 300 divided by 25, so that will be 12. So I know that the solution to this is x will have to be less than or equal to 12 weeks, which means if she wants to have at least $200 left, she can't be spending money for more than 12 weeks. She has to do it for less than 12 weeks. Let's take a look at another one. The yellow cab charges $1.75 flat rate in addition to 65 cents per mile. So that's a rate. It's not it's 65 cents for every mile. Dominic has no more than $10 to spend on the ride. How many miles can he go in the taxi? Well, once again, the thing that you want to set your variable to is what you don't know anything about or what the question is asking you, and it's asking you how many miles. So I'm going to set my variable to the number of miles. And make sure you don't just write miles, because sometimes your variable can be the cost of the miles, the cost of something. So it's not the cost, it's the number of miles. So don't skip using that word number in there. All right. Well, the yellow cab charges $1.75 flat rate. So $1.75, I'm going to have to pay that no matter what. Plus, or in addition, that tells you plus, to 65 cents per mile. Well, I've got plus 65 cents per mile, but I don't know the number of miles, so that's where my variable will come into play. And it says Dominic has no more than $10 to spend. Well, no more than, if I look up here, no more than means less than or equal to $10. So once again, now here I have an equation that I could solve. And it doesn't matter. I could reverse these two. I could have just written this 0.65x plus 175 is less than or equal to 10. That really isn't going to be matter. Addition and subtraction, I can flip like that. I need to get this 175 to the other side. So 0.65x, oops, sorry, I forgot to subtract it. Minus 175 minus 175, 0.65x. Again, all I did was add and subtract, so I can just carry down my inequality sign. You can just take out your calculator if you want to do the math. You can just say 10 minus 1.75, and you'll get $8.25. Now I'm multiplying between x and 0.65. I'm multiplying, so to undo multiplication, I actually have to do division. I'm not dividing by a negative, so I don't have to worry about flipping my inequality. On this side of the equation, I'll just have x. Since there's no negatives, I can just carry down my inequality sign. 8.25 divided by 0.65 will give me a long decimal number, but I'm talking about money, so I'm going to round to 2 decimal places. If I'm rounding to 2 decimal places, I'm going to look at the number next to the 9. It's a 2, so I'm going to keep the 9. So 1269. So I know x has to be less than or equal to 1269, which means that's the number of miles that Dominic has to go if he wants to have at least $10 left. If you have any questions, let me know.